Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra chapter quadratic forms, lecture number 2, in which I will define some terms related to quadratic form and solve some problems. Now we define matrix of a quadratic form. If phi equal to sigma I equal to 1 to n, sigma j equal to 1 to n, aij xi xj is a quadratic form in n variables x1, x2 xn, and there exists a unique symmetric matrix B of order n such that phi can be written as x transpose multiply matrix B multiply x, capital X, where capital X is a column matrix. Here this inside elements B row matrix and its transpose is column matrix. Then matrix B is called the matrix of the quadratic form sigma I equal to 1 to n, sigma j equal to 1 to n, aij xi multiply xj. Next we define quadratic form corresponding to a symmetric matrix. This is matrix of quadratic form, and now quadratic form corresponding to symmetric matrix. Let B is a matrix of size n by n be a symmetric matrix over the field F, and let X is a column matrix. This is a row matrix, its transpose is column matrix, that is column vector. Then transpose of X multiply B multiply X determines a unique quadratic form sigma I equal to 1 to n, j equal to 1 to n, aij xi xj in n variables x1, x2 xn over the field F. Therefore we get 1-1 correspondence between quadratic forms in n variables over the field F and the set of all n rowed symmetric matrices over the field F. That means we have two sets. First set is set containing quadratic forms q1, q2 and second set contains symmetric matrices b1, b2 Since this q1 corresponds to symmetric matrix B1, Q2 corresponds to symmetric matrix B2. This function is F. This F is 1, 1 onto function. That is, F is bijective function. Now we solve a problem. Problem is write down the matrix of the quadratic form of x1 square plus 2x2 square minus 5x3 square minus x1 x2 plus 4x2 x3 minus 3x3 x1 and verify that this quadratic form can be written as matrix product transpose of x multiply matrix B multiply matrix X. Now we solve this. Let phi be the given quadratic form. Let this is number 1. We may write this term minus x1 x2 equal to minus half x1 x2 minus half x2 x1. This is number 2. Here minus 3 x3 x1 equal to minus 3 by 2 x1 x3 minus 3 by 2 x3 x1. This is number 3. Here plus 4 x2 x3 equal to 2 x2 x3 plus 2 x3 x2. This is number 4. Therefore, 1 may be written as here x1 square means x1 multiply x1 coefficient 1 minus x1 x2 here x1 x2 minus half x1 x2 then x1 x3 here minus 3 by 2 x1 x3 then x2 x1 x2 x1 minus half x2 x1 then x2 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 square 2 x2 x2 then x2 x3 x2 x3 here 2 x2 x3 then x3 x1 here minus 3 by 2 x3 x1 then x3 x2 x3 x2 is 2 x3 x2 then x3 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 be here x3 square means minus 5 x3 x3. Let this is number 5. Let B be the matrix of quadratic form. Here we write coefficient of 1 1 1 coefficient of 1 2 minus half coefficient of 1 3 minus 3 by 2 coefficient 2 1 minus half coefficient 2 2 2 coefficient 2 3 2 coefficient 3 1 minus 3 by 2 coefficient 3 2 2 coefficient 3 3 minus 5 and this is a symmetric matrix. This is a symmetric matrix. Here we see that 1 2 A12 equal to A21 A13 equal to A31 A23 equal to A32 and other diagonal element. Let X be a column matrix containing x1 x2 x3. Then transpose of X will be a row matrix x1 x2 x3. This is 7, this is 8 and this is 6. Now multiply transpose of X multiply B. Here if we multiply this, firstly we multiply first row multiply first column, we get this, then first row second column we get this, then first row third column we get this. Now we multiply transpose of X multiply B multiply X and we write this value first and then value of X column matrix x1 x2 x3 and we will get the same as this quadratic form. So our problem is solved. This quadratic form is written as the product of three matrices transpose of X multiply symmetric matrix B multiply column matrix X. Now we solve the next problem. Next problem is write down the quadratic forms corresponding to the matrix. This is a 3 by 3 matrix. Now we solve this solution. Let B be the given matrix. Here we see that here in the position A12 equal to 2 and A21 equal to 2. A13 equal to 3, A31 equal to 3, A23 equal to 3, A32 equal to 3. So it is clear that B is a symmetric matrix. Let capital X be a column matrix containing x1, x2, x3. Transpose of X will be a row matrix. Now we multiply transpose of X and symmetric matrix B. Here, if we multiply, firstly multiply first row, multiply first column. 1 multiply x1, x1 plus 2x2 plus 3x3. Now, first row, second column, 2x1 plus 0x2 plus 3x3. Now, first row, third column, 3x1 plus 3x2 plus 1x3. This is product of transpose of X multiply B. Now, we again multiply with X with this matrix. We write firstly this matrix and then column matrix containing x1, x2, x3. Now we multiply first row multiply first column, means we multiply x1 with this x1 square plus 2x1 x2 plus 3x1 x3 plus we multiply x2 with this 2x1 x2 plus 0 x2 square plus 3 x2 x3. Now multiply plus x3 with this 3x1 x3 plus 3x2 x3 plus x3 square here, and we get 3x1 square plus x3 square plus 4x1 x2 plus 6x2 x3 plus 6x1 x3, and our quadratic form phi equal to 3x1 square plus x3 square plus 4x1 x2 plus 6x2 x3 plus 6x1 x3 is the quadratic form corresponding to the given symmetric matrix. This. So our problem is solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button, and if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.